Hello everyone. For my capstone project, I chose fake news classification and prediction. I have done this project under the guidance of Professor Shaoji Wang. The contents I would like to present in this project is introduction, exploratory data analysis and pre-processing, modeling and evaluation. So, as we all know that fake news is information that leads people down the wrong path. Nowadays, fake news spreads like wildfire and people share it without verifying it. This is frequently done to advance or impose certain ideas, and it is frequently accomplished through political agendas. To generate online advertising revenue, media outlets must be able to attract viewers to their websites. Hence, it is necessary to detect fake news. Most of what happens every day has been reported by news media and other forms of mass media. In recent years, the reliability of information on the internet has become an important issue in modern life. People are so affected by fake news on social media and the internet that it must be stopped. So the goal of this project is to make a good model that can tell if a piece of information is true or false. Coming to the introduction part, fake news is spread in order to gain online fame and money. People want attention, which they can get by growing their social media following. They can get more followers by creating and spreading fake news stories. Moreover, by increasing the number of views on their advertisement, fake news creators can increase their revenue. So, various machine NLP approaches, machine learning, and artificial intelligence can be used to detect such unrealistic news items. Such websites can be available in various countries. So, hence, fake news is both a global and worldwide issue. Coming to the framework, I have downloaded the data sets fake and true. Then I have done some pre-processing of data like cleaning, performing some exploratory data analysis, exploring the data. Then I have done some text pre-processing like removing stop words, URLs, unnecessary special characters, and yeah, and then I have splitted my data set into train and test. I have performed some factorization using TF-IDF factorizer. Then I have built a few machine learning models like logistic regression, random forest, and decision tree to see which model performs better for this data set. And I have validated the results and the performance of the model. Dataset description. I have downloaded these data sets from Kaggle. There are two data sets, one for fake news and the other for true news. In true news, there are 23,481 news articles, and in fake news, there are 21,417 news articles. This data set has no missing values, otherwise, we had to remove that information or impute some values. Um, Among the features, there are title and tag, subject, date, and label. Under the subject, there are like several categories of news topics, like, including political news, world news, government news, left news, etc. Here, the exploratory data analysis starts. I have plotted a distribution plot for fake news and real news. We could see that there is equal distribution of the classes. So these classes are nearly balanced. It means that the data is not suffering from imbalance. Then I have extracted top like top news from this subject. We can see that the article belongs to the political news. um, these articles are more like news article sources than proper subjects. Next, I have performed some text processing. Since the text come from online publications, it need to be processed to get rid of links, URLs, emojis, and clean it up. Text data can't be used directly because it has words, special symbols, and other things that can't be used. If you use it without cleaning it first, it will be hard to find patterns in the text and may sometimes, cause an error. Because of this, we must always start with text data that is clean. I've concatenated the title and text together because the title usually gives one or two sentence summary of the article, which can help you spot clickbait articles. So I've checked for null values and duplicate, and I have done some text casing. I have removed the stop words. I've removed punctuations and URLs or website taxonomy, and I have done some tokenizing. This is the distribution plot of the text processing, and from this graph we can see that the distribution um, plot this distribution plot infers that most articles are having words less than 500, and these are the frequently occurring unigrams in the uh, text. And as we can see that Trump said president are the most frequently occurred words, and these are the bigram in the words that occur in the review text. We see that Donald Trump, United States, White House, these are some of the most frequently occurred words. Then these are some of, I've extracted some of the frequently occurring trigrams in the review text, and President Donald Trump, Twitter, featured image. These are some of the most occurred words in the text. From all the three graphs, we can see that since the text belongs to political news, we can uh, we can see that most frequently repeated terms are Donald Trump, Barack Obama, like president, which indicates that the topic is about mostly presidential elections. These are some of the frequently occurring words in fake articles, and these are some of the frequently occurring words in real articles. I have performed some sentiment analysis to see if articles are reacting in an optimistic way or a negative way. If there is some significant difference between the true and fake articles, then these sentiments can be used as features. So from this graph, we can see that due to the length of the articles, most of them are having the polarity score around zero, which suggests that it is neutral. Hence, we can ignore these features. And here we can see that there are few more negative and positive articles in fake news rather than the true ones. Neutral seems like proportionately distributed, as there is no significant difference. We can safely ignore these features for now. Oh, sorry. The modeling, as I've already told, I've performed some text processing like cleaning, performing some remove special character removal, then website URLs and removals, and I have performed some tokenizing. Then I've performed vectorizing using TF-IDF vectorizer. Then I have done classification like model training, predicting and validating the model performance. TF-IDF factorization, as we know that it is a popular algorithm for turning text into meaningful representation of numbers, which can be used to fit machine learning algorithm for prediction. TF-IDF vectors are similar to one-hot encoded vectors, which say that the words are used a lot but can be found anywhere, should not be given much weight or importance. We can think of this as being like the English word, or and they aren't very useful. I have extracted the top 10 TF-IDF features to see which features are having good weightage for classification. And here we can see that Trump we Trump is having, for the true news, Trump is having more weightage, and for the fake news, said Trump reuters are having more weightage. Then I have performed some machine learning model classification models like naive Bayes, decision tree, random forest, ADA boost, where the accuracy for naive Bayes is 98.6 and for decision tree it is 99.6. For random forest, the accuracy stands at 99.8%, and for ADA boost, the accuracy stands at 99.7%. When comparing all the models, we see that random forest is the best model that perform is the best perform model compared to naive based decision tree and ADA boost. Um, this is the AUC and ROC curve for the random forest classification, and as we can see that the ROC curve shows that both the true positive and false positive rate are close to 1.0, and the area under the curve is also 1.0, indicating that the model is performing well in classifying the news. uh, so on I yes, that, and these are some of the references I have used for my project. Yeah, thank you.